And Ado, I'll turn it over to you to introduce our first speakers.
Thank you, Dan. We have a great presentation to begin in our TechCast day. We're going to find out how it was the Oracle Analytics Cloud implementation at Hartford Healthcare. We have the pleasure to receive Ravi Murikipudi and Hyder Mehtawala. Ravi is an OBI developer from Hartford Healthcare, and Hyder is the analytic manager of Deloitte. So, guys, the audience is all yours.
Thank you, Adele. First, let me share my screen.
Anything, right? He said, yeah, I'm going to talk to them. ऐसा बोला था yesterday.
Can everyone see my screen?
Yep.
Yes, we can see your screen.
One thing that I just forgot to mention, and it's important, is that please, everybody, if you have any questions, just write it in the Q&A box, not in the chat box. And if we have enough time, we're going to read your questions aloud at the end of the session. Okay, thank you. Go ahead, please, Ravi.
Thank you, Adele. So, hello everyone, good morning. We are here to present our Oracle Cloud implementation at Hartford Healthcare. So I'll quickly go through the agenda for today. So we want to tell a little bit about HHC. Hartford Healthcare is in short called as HHC. About Deloitte, our implementation partner at HHC is Deloitte. So we both are presenting it together. And our journey, our journey in OAC and with OBIA, the architecture we defined, the security, how we designed it, the sizing of the OAC environments, the custom plugins, and the machine learning part of it. So by this time, most of the people know that they can lift and shift their RPDs and catalogs to OAC. So we are not touching that part because that we are assuming everybody kind of know how to do it. So we are touching some of the design aspect on the architecture part and the custom security, complex custom security that we have built and how we have enabled it in OAC and how we basically size the environments and the plugins and machine learning as well. So like I am Ravi Murikipudi. I am a senior OB developer with HHC. I have 13 years of experience with Oracle BA solutions across all the modules, hands-on implementation on OBIA, implementation and maintenance of OBI environments as well. So over to you, Hyder.
Thank you, Ravi. Morning, everyone. My name is Hyder Mehtawala. I've been with Deloitte for more than 5 years now, and I'm primarily aligned to the strategy and analytics practice within Deloitte. Overall, I've been working in the Oracle BI space for more than 10 years now, and more recently, I've been involved on multiple implementations that included BI apps and OAC. In terms of industries, I'm primarily focused on healthcare, but have also served clients in the FSI and the life science industries. In today's session, I'll be primarily talking about the custom plugins that we have developed and introduced at HHC, and some of the ML use cases that we are currently focusing on as part of the implementation. Now, a quick intro about the analytics community within Deloitte. Now, Deloitte has a strong group of consultants spread across the globe in the data and analytics space who serve clients across multiple industries. In the recent 2020 Gartner report, Deloitte was named a leader for the 6th consecutive time in the data analytics service providers worldwide. Now, Deloitte has been the implementation partner for HHC to implement Oracle BI apps. When we started off, the primary focus was to set up an operational analytics platform with the primary focus on getting data from PeopleSoft HR and PeopleSoft Finance. But over the last couple of years, as Ravi would highlight, we have introduced multiple source systems and we are consuming data from different sources. And also in terms of the reporting platform and the capabilities, there are multiple things that we have focused on in the last 2 years. So with that, I'll hand it over to Ravi again to provide a quick intro about HHC and walk us through the first part of the presentation.
Thank you, Hyder. So going to the next slide, Hartford Healthcare is a comprehensive integrated healthcare system within and in and around Connecticut state. We are a workforce strength of 30,000 plus and 4.3 billion in operating revenue. So going to our journey with HHCBI, the application, we call it as HHCBI. So the implementation started in and around FY 2017, and by 2018 we had the basic foundation of HHCBI built around HR, finance, and procurement and spend modules. We started slow with 50 users. At that point, we were all on-prem. And one by one, we started adding the security part of it and adding more and more visuals around 2019. And by 2019, we have expanded our our dashboards significantly, and the user base also expanded to 1,000 plus users. And in FY20, we went live with OAC in April 2020, and we have around 1,500 active users as of now. And the projected number of users we would be around 3,000 plus is our projection. And we are, as I said, we are adding more and more dashboards, the predictive insights, and also many active or very advanced data visualizations in this 2020. And moving our application to OAC has given us many benefits. So we'll be walking through those benefits in the next few slides. So quickly touch upon the architecture. Ours is a hybrid cloud architecture. So meaning the left part, whatever you're seeing on the left side of the diagram is on-prem, mainly the PeopleSoft source databases where we connect and pull our information from. It is one of our sources. We have many sources, but PeopleSoft is the main source. And we have 11G servers where our ETL ODI is installed, and ETL pulls the information to our data warehouse, which is also on-prem. So apart from that, we have a couple of machines where there are remote data gateway installed, and also some Python scripts and AD Bridge configured. So I'll go through this part in detail in the next few slides. This is more or less related to security. And on the right side of the diagram, you'll see Oracle Cloud. So all our environments, we have 4 environments, and all our environments we have turned on in OAC, and basically the remote data gateway connects between the OAC environments and the data warehouse that we have on-prem. And also we have usage tracking part, that is the information regarding what dashboards and reports have been used, and that information is collected in autonomous data warehouse, which is also on cloud. So the main component here, which is a security gateway, I can say, is IDCS, Oracle Identity Cloud Services. And I'll be mostly covering how we have leveraged IDCS to basically have our on-prem security model migrated to OAC. So the diagram on the right gives you a small snippet of how it is done. So IDCS is on cloud, and we have MSAD and active, and there is a AD Bridge configured. So you can configure AD Bridge pretty easily. There is a link published by Oracle, and the steps are pretty much straightforward, and we have followed the steps and configured the AD Bridge. So essentially what I'm trying to say is we have a complex security model on-prem, meaning we are piggybacking on PeopleSoft workforce security model, workforce grid per se, and the same security model is replicated in our HHCBI. So, and apart from that, we have a n number of custom roles that are assigned to users, and all those custom roles have been migrated to IDCS. So in short, if I want to show, this is our starting point. So this is my role user, and these are all the role names that I have. And all these role names are custom, and all these role names have been migrated to IDCS. So at the end, you would see that my name has been assigned to all these roles in the IDCS. So how we achieved transforming this the roles that are within the defined in the table to IDCS is what I'll be covering next. So as you can see, we are achieving through Python scripts and REST API calls. So we have 5 Python scripts. So the first script will connect to the data warehouse and extract the user group information into a CSV file. That CSV file is stored in one of the location within our on-premise machines. So this input is passed into another Python scripts, which actually does transform it to a CSV file, and then again it will chunk the users and the user grouping mapping. So after that, using the above input, another Python scripts gets REST API calls, which will connect to our OAC tenancy, and which will get the user mapping information, which is already present in the IDCS. So this is done to get the delta between what is there in the custom script that is generated as step 2, and also what is already present there in the IDCS. So after that, there are 2 scripts that will run. One is to assign users and one is to revoke users using the delta. So assign users will assign the roles in the IDCS using the, if for example, a new user is assigned a role today, that user will be assigned the role in the IDCS as well, as taking the input from the script. And if a user, for whatever reason, has left the company, or if there is a change in the BU and department allocation or role allocation or whatever, right? So then that user roles and responsibilities will be revoked from the IDCS as well. So by with these 5 simple steps, we have achieved migration of our role information or authentication part and authorization part to the IDCS in the cloud. Coming to the next part is sizing the environments. So this is the first and foremost burning question we had when we thought we'll go to cloud. So what should be the size of those CPUs and how they should be defined, and there were a number of questions. So to tackle this, what we did is we took a list of 10 heavily used dashboards within our environment, and we have used a script. We have used a tool called JMeter to basically generate a script that a user is attempting to run all the 10 dashboards at some point of time. So we took that input and we basically had conducted stress tests with multiple settings. For example, we have turned on an environment with 4 CPUs, and we have leveraged the JMeter script to say that it is projecting 50 concurrent users and see how was the performance. So we analyzed the performance of our environments using these kind of graphs that are shown here. So each vertical bar is one dashboard. It might not be clear here because we have a number of reputations and a number of dashboards, but in general, each vertical bar is a dashboard, and to the left is the nanoseconds it took, microseconds it took to execute the dashboard. So by comparing these graphs after each iteration, we have found our sweet spot for the number of OCPUs we have to be turning on in our production environment. Say, for example, going through the previous usage tracking data, we came to know that there are at some point or any point 100 concurrent users in our environment. So we have simulated the script with 100 concurrent users with 4 OCPUs, 6 OCPUs, and 8 OCPUs consistently. And then we saw these graphs, we compared these graphs and saw where we have the correct sweet spot for the performance. And one thing I would like to give kudos to Oracle here is if at all you are in doubt and if at all you are not sure, you can engage Oracle team they'll help you a lot with managing with telling you what's wrong or what's going right by verifying the logs on the cloud, and it gives you immense confidence when you're planning this kind of activities. And another thing that we learned from Oracle is again how to verify your RDG logs, how to read those logs and see if the remote data gateway logs are saying something, or if there is anything fundamentally wrong, going wrong in the setup of the RDG, or if there are any performance issues, or if RDG is acting as a bottleneck. In our case, RDG was not the bottleneck and our logs were all clear. So we went ahead and sized our environments, dev, test, and prod with the correct OCPUs. And so far, it's been good. Nothing to report actually. So the key considerations I would touch upon is again the total sizing and complexity. Sizing actually depends upon the complexity of the reports and also the number of dashboards you have on the in the environment, and also the number of reports on each dashboard you have on the environment. Say for example, you have a dashboard with 10 reports on it, and one user lands on the dashboard, all 10 reports will be running. If it has 20, the resources that that OAC gives will exponentially grow. So it worked for our case, but each and every case is different, and you have to be cognizant of this fact that it totally depends upon the complexity and the number of reports that are running. And also, like I said, that there should be multiple iterations that are necessary to finally come to a sizing consideration of what your environment should be. And again, all we can do is we can do a number of stress tests from the machine perspective, but again, involving key stakeholders from business and other areas to see how it actually feels when a user is running, when user runs the report in the backend, when we are actually simulating the stress test. So we have learned a lot from involving the stakeholders early within those stress tests as well. And like I said, you can engage Oracle to monitor performance of BA servers if necessary. We found it very useful, and Oracle was very cooperative on this as well. And over to you, Hyder, to take us to the next parts.
Sure, Ravi. Thank you. So Ravi, let me pull up my screen. So let me be doing something. So. Everyone. So in the next couple of sections, what we are going to cover is in terms of plugins, what are the additional things that we have done specifically at HHC around visualization plugin, and even the more recent data action framework that was introduced, where an option is provided to extend that out-of-the-box capabilities. We'll touch upon those as well, and specific use cases where we have used that functionality. And towards the end, what we are going to cover are the specific machine learning use cases that we are currently working on, and also some of the ones that are right now on the roadmap as part of the HHC's journey. Now, let me start with the visualization plugin. So as you can see, in terms of the out-of-the-box visuals that are available right now on the data visualization platform. So what we have is around 40 plus, and this list keeps on increasing with each and every release. We have a broad set of visuals which are already available in the data visualization platform that can be leveraged. Now, for each of these visuals, again, there are multiple properties controls given to kind of control the behavior of the visual. But there are instances where you need a different kind of visual for a specific scenario, or you want to use the similar visual with more control on certain properties of the visual. So in those scenarios, what we typically have is there is an extension library or an analytics library which is provided by Oracle, which hosts a number of extensions which different groups have currently created and uploaded on that library. So these additional plugins can be easily downloaded, configured, and be used in a specific DV project. So that functionality is already provided. Now, in addition to that, what we can also do is use the Oracle DB SDK and the JavaScript libraries that are provided to create or extend some of these custom plugins that are available for specific use case or scenarios that are required as part of a particular implementation. So having said that, now at HHC, I'll just touch upon a couple of use cases where we had to kind of create or extend some of these custom plugins and use those as part of specific dashboards that we had already built for the users. So the first screenshot that you see on the right-hand side, it talks about, it shows a visual that has not only a bar chart, but along with that, there is a section included at the top that gives the KPI value and certain change indicators in terms of comparing the value with prior year, budgets, targets. So what we have introduced right now is all this is currently put into a single visual. Like we can do this as part of different visuals. I can have a separate tile, I can have a separate visual for the change indicators and a bar graph. That was the earlier setup that we had, but it had some issues in terms of performance, in terms of how it used to appear on mobile screens. But to address some of those asks, we created this custom plugin that we are in the process of validating and implementing across the board. Now, apart from that, the two visuals at the bottom, as you can see, these are again, we call it mini tiles at this implementation, but essentially what it allows us to do is show a high-level KPI along with the change indicators. So this was a very specific ask. A lot of this can be done with the out-of-the-box tile, but to address some of these specific needs with respect to showing the change indicators, we made some extensions, made some changes to the custom plugins that were available to cater to this. Let me quickly bring up and show how does it look like once we have it in the DB platform. All right. So as you can see, currently we have a couple of versions which are available for the horizontal and the vertical bar. And as you can see, this is all embedded in a single area. These are not different visuals, but rather it's just one single visual. There'll be one query which will be fired to get all the data elements that we are looking over here. So essentially there are four pieces. There's the KPI, there's the change indicators, and the visual at the bottom. The controls that you see on the left have been provided to change and configure most of those things that appear over here in terms of the data, the format, and the look and feel of the visual. So a lot of controls have been provided in this section. And also the other functionalities in terms of showing the data on hover and enabling functionalities on the things that typically appear on right click. I can have a data action, I can drill to a certain page. So those functionalities have also been enabled on these custom plugins. Some of these things like the mini tile, what we have done is there was an ask to show this in different places. For example, here I can either show the percentage change at the bottom of the KPI, or we have provided controls which can easily switch this to the right-hand side if needed based on the layout and the format of the dashboard where we are including this. So I'll quickly move on to the tech again. So this was around the extensions that we had done from a visualization standpoint. Let me quickly jump onto the next part of it. So in terms of data action, so as you might be aware, there are 4 out-of-the-box data actions that are currently available, which allows us to do a lot of different things. For instance, if I want to navigate to an external application, I can use the URL navigation option. Or if I want to navigate by passing the context of this current page to the target page within the BI platform, I can use the analytics link option. So a lot of options are already provided. But apart from that, what we also have now is the data actions plugin. What it allows us to do is extend the behavior of this out-of-the-box data actions that are provided. Now, there are certain libraries that can be referred to extend these. And again, with the same setup, the Oracle DB SDK, this can be extended further to provide custom functionality. On the library, which Oracle hosts right now, we have 1 or 2 custom data actions that have already been published that can be readily downloaded and used for a very specific purposes. Now, apart from that, what we have also done is we have used this platform or technology which was provided to Extend to overcome one of the scenarios that we had at this implementation. So one of the things that we have been doing in the last few months is, after creating the DV projects, we have been embedding these DV projects in the BI dashboards. And as soon as we do that, if there are any action links that are on the DV projects, they do not appear by design. So to overcome that, we had extended URL navigation data action, and we created a custom one to support this behavior, wherein with this, what we are able to do is we are able to capture the context of the page and pass it to the target page where we are navigating. So we were able to use this platform and functionality to extend the out-of-the-box behavior of the data actions that are currently available. Now, having said that, I'll quickly jump on to the last section of the different things that we wanted to cover today. Now, the other, as you saw when Ravi talked about the HHC journey at the beginning, right? We started around a couple of years back. Focus was mostly around the descriptive piece, but now, as and when we are moving, we are planning to include more of predictive and prescriptive stuff, and OAC as a platform has provided a lot of opportunity to do that in a seamless manner. So here on this slide, what we are covering are some of the key elements from a machine learning standpoint, which the platform already provides. So for instance, one of the areas is data preparation and advanced analytics, right? So as we are aware, there is a functionality wherein we can upload a file to OAC, and it will automatically suggest some of the transformations that it believes can be incorporated. Again, this is all automated. We do not have to specifically write code for this. We just have to select what we need, what we don't need, and OAC can do it for us. Similarly, when we talk about advanced analytics, there are a lot of advanced functions available. Especially, it can be included just on the DV project directly, or if it's more, there are ways provided using data flows and other things that are available on OAC. It can help us use those capabilities provided in the form. Recently, the NLP capabilities as well has been really powerful to interact with the platform in a natural language manner. So those capabilities that have been introduced as well are really powerful. So again, jumping into the specific use cases that we are looking at HHC. So one of the use cases that we have started working on in the last couple of months is around the employee attrition prediction. So again, for this use case, the target is to identify those set of employees which are at risk of leaving the organization, and also identify what factors contributes to those employees leaving the firm. And also the algorithm is expected to predict by when, as in, is it they're planning to leave it right now, 3 months down the line. So there are different aspects that we're trying to predict. And for this use case, what we are using is Oracle Data Miner. So now the algorithms and the overall package, what Oracle Data Miner provides is very powerful, in the sense, the first advantage that we definitely get is the fact that it's all embedded within the database. So we really don't have to move the underlying HR specific data that is already available in our warehouse. There is no need to move that out of the database. We are still able to do the prediction using the data which still resides in the database. So that allows us to save time on the data movement, and also from a security standpoint. Since it's all there pretty much in the database, we are not moving it out. It's highly secured, and there are other controls available as well to kind of control the security aspect. So that has been really powerful. And so far, whatever work we have done in the last couple of months, the feedback that we have got from the specific group that we are working with has been very good. And the results that we got from the classification algorithms that we are using as part of ODM has been very fruitful. So we are still in the process of finalizing some of the content around this, and it will be productionalized maybe in the next couple of months once we take care of all the other key factors as well. Now, apart from this use case, there are other ML use cases that are on the roadmap for HHC. First, it's around the journal anomaly detection. So here we are working closely with the finance group at HHC to see if we can leverage some of the advanced analytics capabilities that's provided within OAC to detect outliers or anomalous journal entries that might be posted during, say, the month-end process. So we are focusing on that and hashing out other details in terms of how we can materialize this specific use case. The other use cases, again, are focused on the finance and HR areas around predictive forecasting and also workforce planning. So workforce planning would primarily focus on creating the predictive forecast models to see and forecast the demand for workforce in different areas. So these are other use cases that are on the roadmap, which we'll be working on. So again, with that, that brings us to the end of this presentation and the topics that we wanted to cover. So we'll take a pause and we'll see if there are any questions
Thank you.
would like us to address.
Thank you so much, Ravi and Hyder. Yes, we have two questions. The first one is from Chris Bolin, who asked, who developed the custom plugins developed at HHC? It was HHC or it was Deloitte?
It was a joint effort where we have been working with HHC as well to customize those plugins, and we have got some good support from Oracle as well. While we are developing these plugins, Oracle has been very helpful to help come up with any kind of issues that we have been facing while creating these plugins.
Perfect, thank you. Another question that we have is about the NLG module. Which languages it supports?
So in terms of language, if you're referring to the ones that are available right now, again, I've seen most part of it as English, but I need to check if there are other things supported. So I cannot answer that right away, but I need to check and get back if needed.
And I can help as well regarding this. I'll paste, and there's a couple languages, around 20 some, that I just pasted into that answer. So they should come through in a moment. But they are Danish, German, Greek, English, Finnish, French, Hebrew, Croatian, Hungarian, Italian, Japanese, Korean, Dutch, Norwegian, Polish. Yes. A lot of them, yes, a lot of languages.
Okay. We have also another question from Antonio Gomez. Sorry for my understanding if I thought that data miner is part of the machine learning in database. Yes, it comes with the database. Is that the case? Algorithm was developed in database and used it into OEC. Do you want to tell us about it, Ravi?
Yes, that's correct. So Oracle Data Miner is pretty much part of the database, and the algorithm was run and the output was captured in the tables, which was again consumed in OAC. So yes, that's correct.
Perfect. Thank you so much. Thank you so much, Ravi and Hyder, for this great presentation. And thank you so much for this. And we are going to continue with the